Okay, we're going to get started. We have Jukka Lehtosalo and David Fisher. Thank you, guys.
Thanks, Tim. So my name is David. This is Jukka. We've been working on Python static types, more specifically mypy, a Python static type checker at Dropbox for the last while. And we're here today to tell you all about it. More specifically, we'll start with talking a little bit about the motivation behind our work on this, why we think static types are important. Then I'll show you a brief live demo of what it would look like to add static types to your code, what static types look like, what interacting with mypy is like, all that sort of thing. Then Jukka will talk a bit about how mypy works internally. There's a lot going on, but it'll focus on a particular interesting part of it. And then we'll give you some tips for annotating an existing code base, and finish up with our experiences at Dropbox and how we found it so far. So to start with, let's talk about why are we doing this whole static typing thing anyway? Well, one big reason is to be able to answer a question like this. What does this code do? If you're in a large code base, this may be a common experience. You have some two-line function that's pretty simple on the surface of it, and you need to understand what's actually going on. Unfortunately, it's not a super easy task. Let's say you want to know what entry.data.validate does. How might you actually go about figuring that out? Well, you could grep for a validate method, but in a large code base, you're going to get a lot of results. In Dropbox's code base, we have 154 results. And these aren't related by some common superclass or anything. It's just a popular method name. So that's not really that helpful. We don't really want to have to read through all 154 validate methods to try to understand which one this might be. So if we knew what an entry.data was, we would be able to figure this out. And we could know that if we knew what an entry was, which we could know if we knew what an entries was. But how do we figure out the type of entries? We could try to guess from context, but in this sort of function, that's not really helpful at all. So we could grep for call sites of validate entries, but now we're kind of just back where we started. We may have to look through maybe there's a lot of call sites. Maybe some call sites pass in one sort of entries, and some call sites pass in another. It's easy to miss one of those. So we are potentially having to read through thousands of lines of code just to be sure we understand what these 3 short lines do. And this is not a great place to be. It takes a long time and can be a bit unreliable, and is just generally not super fun. So how might we go about fixing this? Well, this is a big enough problem that some people have suggested rewrite all of our code in a statically typed code base. This is in spite of the fact that we have 5 million lines of Python code, and this would take far, far, far too long. This is also notoriously a way to end up having your company crash and burn. Joel Spolsky wrote a great article on this about Netscape. And finally, Python is pretty hard to beat. We're here because we're excited about working in Python. I assume that's why you're all here too. And so we don't want to do this. We want to stay with Python. So all right, that's no good. What are some other options here? Well, potentially we could add some sort of special doc strings or comments where you always write the type in. And this works OK at first. Now you have the type next to the code, and you can figure it out easily. But people forget to update them over time. And this can happen for a variety of reasons. Even with good code review and the best intent, sometimes you'll make a change far away in the code base that ends up having some effect on the types downstream that you don't even really know about. And so over time, you're almost certain to end up with some percentage of these doc strings no longer being true. And once they become untrustworthy, they start very quickly to become useless. After you've been burned by this a couple of times and gone on a wild goose chase for a few hours, you no longer are willing to trust any of the doc strings, even if only a few of them are incorrect. And this is a pattern that we've seen in a number of large code bases. So this is not going to work for us either, unfortunately. Another option that some have considered is doing type inference through the whole program. So don't write anything else in the code and just have some really, really smart analyzer that is able to understand your millions of lines of Python and tell you what the types are. And sure, the types aren't in the code, so you'd have to have some utility that displays them, but that seems potentially possible. But there's a bigger problem, which is this is an unsolved problem. Nobody really knows how to do this. They do know that it's very difficult, but no one so far has done this successfully at a very large scale. And worst, if you have some dynamic part of your Python code base, then that will blow the whole thing up. the static analyzer will, or the whole code-based type inferencer, will look at that dynamic part. It won't be able to make heads or tails of it if it just does something truly dynamic. And it'll not be able to make any inferences about your code as a whole, or at least very limited ones. So that won't work for our purpose. So OK, what can we do? Well, what if we added static types to Python? You'd have to be able to introduce them gradually. Otherwise, you'd be back to the rewrite everything in a static language problem. But this is possible. It would document types right where you want to see them. And it could check that documentation to make sure that it stayed correct. It would still be a lot of work to implement, and it still had some legitimately unsolved problems. But it was doable, and we've done it, and it works. And we're using it at Dropbox on 700,000 lines of code, and a number of other companies in the industry, like Quora and Facebook are using it, as well as big open source projects, like Zulip. So we're very excited about that. And that's what we're here to talk to you about. So I've talked a lot about why we've done this. Let me show you what it is that we've done. So I'm going to attempt to do a live demo, because those always go very well. And to do that, first I'd better show you my screen. And it would be really great if the mirroring would show up, but maybe it won't. So let's just do this. Huh? Command F1? All right, let me try that. Well, this didn't happen in run through, so we'll figure it out. I'll use that. Sorry for the slight technical difficulties. Great. Nope. Pardon me. Sorry for the fiddling. Great. So, all right. So I can sort of see my code. So that'll be exciting. Probably don't need this Vim help file right now. Great. So I have here a pretty simple bank program, which I will endeavor to view. As you can see, it has an account type. There's a bank class where you can do things like get a particular account by name, where you can do things like open an account that gets some starting bonus. You can deposit money in an account by name. And you can also have this module level function, which, given a bank and a list of names and some amount of money, donates to all of them. Great. So let's say we want to start mypying or type checking a program like this. The first thing that we'll want to do is install mypy with python 3-m pip install mypy. I've already done this, so I'm not going to run it again here. And now we can run mypy on this program. Before I do that, I want to go back to something that I said earlier. A really important part of mypy is that it's gradual typing. That is, that you can introduce it gradually into a large code base. And what that means is, if you don't have a function, if your functions are not yet type annotated and they don't have any static types, mypy will be very, very permissive on them. It'll try to not really look into them and not type check them at all. And this is so if you have a really, really large code base, you can start type checking it from one part and gradually spread. And you don't get 1,000 type errors just to start. So in this case, because we haven't added any type annotations, when we run mypy and banks.py, we will see that it returns no errors. Totally clean bill of health. Now, there are in fact errors in this program, and we will discover one of them shortly. So let's start by annotating open account here. So you annotate functions by giving their arguments types. And you do that in Python by saying argument name, type. So in this case, name is a string. And we have initial balance, which is a float. Now, you don't really want to have a bank with a float balance, but this is a questionable bank, so we'll go with it. And open account doesn't return anything, and here you write that as arrow none, because all functions, if they don't have an explicit return statement in Python, will implicitly return none. So we can run mypy on banks.py and see, oh, hey, on line 30, there's a problem. Which is line 30? This is line 30. We're saying initial balance plus sign-up bonus. It says, hey, you're trying to add a float and a string. And if we look, we see, oh, look, our sign-up bonus here is a string. That's probably not good. We want that to be a float. Well, really, we want it to be an integer number of cents, but this is a questionable bank, so we want it to be a float. So let's fix that. And now we can see that mypy is happy. So this is a kind of simple example of type annotations and the kind of errors that mypy will give you. So let's continue on and annotate this deposit method. So here again, we have name that's a string. We have amount, and that's also a float. And we can see that this function returns a float. Well, it doesn't really return a float. Sometimes it returns none, but I'll get back to that later. And as we can see for now, mypy is perfectly happy with this. And I want to note that all of this is totally valid Python. As of Python 3, you can put this annotation syntax in arguments. We're not doing any crazy transpiling to run this. It's just normal vanilla Python. And also, I want to note that mypy is all running ahead of time. It's kind of like a linter on steroids. There's no type checking happening at runtime here. And that means that you can add types to your program without making any semantic changes. So moving on, let's annotate this donate method down at the bottom. So it takes in a bank instance. This is a user-defined class, but you can talk about it just like you talk about any built-in, with the name of the class. So we just say bank:bank. And now we have a list of names. So, well, you might think, OK, great, we can just put names:list, but that would be a little bit sad. We wouldn't know anything about the type of the items in the list. And so we've introduced the typing module with some useful classes that let you talk about this. In this case, it's capital L list, and then you can use square brackets and talk about the item type. So in this case, it's a list of strings. This capital L list needs to be imported from typing. So from typing, import capital L list. And now that we've done that, going back to the bottom of the program, this should be valid. And then finally, it takes an amount each, which is a float, which you've seen, and returns, I believe, also a float, the amount total that's been donated. So we can run mypy on this and see if there are any errors in this function, and find out that indeed there are. There are 2 errors. It says, hey, your first argument to bank.deposit is a float, but we expected a string, and your second argument, vice versa. And if we look up here at bank.deposit, it takes a name and then an amount, but here we've given it, down here, we've given it an amount and then a name. So we better switch those. So now that we switch those, we can run mypy again and see that we have a clean bill of health. So what other sorts of things would you do with mypy? Well, let's annotate the init method of this bank class. So again, this should be old hat by now, name string. The init method itself returns none, if I can type. And so that's annotated as returning none, even though the constructor of the class will, of course, return a bank. MyPy will understand this line, self.name equals name, to imply that bank's name member variable will have type string, because it sees that name is given as type string to this init function. On this line, well, let's run mypy and see what it says. It says, hey, need type annotation for variable. I understand that this is a dict, but I don't know what the key and value types are. And you really want to know what the key and value types are to get useful information out of this. So to talk about that, that's very much like the capital L list. We can use capital D dict. This is a member variable, and in Python 3.6, there's been a variable annotation syntax, which looks a lot like the argument annotation syntax, which is just variable name :type. So we can say self.accounts :dict, open square bracket, and it takes a string and returns an account. In earlier versions of Python before 3.6, there's a comment syntax for this, which we'll show briefly later. And now mypy understands what kind of dict it is, or it would if I'd imported dict from typing, which is a very common thing to forget. But mypy helpfully tells me, and now it's happy. And we can see that it uses this knowledge of dict to type check other functions. So if we annotate this one, name's a string, it returns an account. And you can see that we do something a little silly and look up the account by the length of the name, which is probably not what we want to be doing. And sure enough, mypy says, hey, you're using an int here when you really mean a string. And yeah, in this example, it's pretty clear just from looking at the code that you probably don't want to be doing this. But it's pretty common that either the key type of the dict is not necessarily obvious from context, or you've called some function that you're going to pass as the key, and it returns a different type than you thought. And so getting errors like this is actually very useful. So now we can run mypy again and see that it's happy. Great. So now I want to go back down here to where I hand-waved over this returning float and talk about a slightly more advanced feature of mypy that is going to be default soon, but isn't quite yet. So if you look at this code, you'll notice that if the bank account exists, then we return, we deposit something in the bank account and return the amount deposited. And if the bank account doesn't exist, we'll just return none. This is all well and good. But the way we use this in donate is we unconditionally add the return value to amount total. If you try to add a none and a float in Python, that's going to blow up at runtime. And it'd be really nice if mypy could catch this for us. Thankfully, it can. Right now, you have to use this option called strict optional. So you can say mypy strict optional, and you'll see why it's called that in a second, banks.py. And now it will complain to you about the return type of deposit. It says, you're claiming to return a float here, but sometimes you return none. So either this none return is incorrect, or your return type is wrong. So we really want a return type that says, sometimes this is a float, and sometimes this is a none. And the way you write that is with this type called optional. So you say optional float, and optional is yet another one of those things imported from typing. Yep. And now mypy understands that this function will sometimes return float and sometimes return none. And it'll be able to check its uses to see, to ensure that you're dealing with the none properly. So in this case, here I'm going to clear my terminal and run it again so you can see it a bit more clearly. It says unsupported types for plus, float, and optional float. And then that's on this line down here, where amount total plus equals amount deposited. What it's saying there is, hey, it's not safe to add a float and a none, so you better do something about that. And, well, what we would do if we wanted to fix this program normally is check for a none. So we can say if amount deposited is not none, then go ahead and add it to amount total. MyPy is smart enough to understand this. Jukka will talk, oh, maybe if I type things correctly. Is it a semicolon? Oh, it needs indent, thank you. Great, so now that it's indented in actually valid code, MyPy is able to type check it and see that this is valid. We have, in fact, checked that amount deposited is not none before doing anything with it, and so MyPy understands that for the scope of that if statement, it really is not none. Jukka will talk a little bit about how that works in the next section. And that's all we have time for now for the demo, so I'm going to hand it off to Jukka to tell you about how this works.
Okay, to help you understand how mypy works, I'm going to talk about a specific thing about mypy internals in a fairly abstract way. This thing is called symbol table. It's an internal mypy data structure. There's one for each module, each class, and each function. It's kind of like the static kind of equivalent of like a runtime namespace, but it's slightly different. So it's a map from a Python name to a type, and this is a static type. So we've seen some examples of static types, such as like list of ints and optional float. And those are slightly different, again, from runtime Python type objects, which are just classes. Symbol tables are a static construct, so they don't exist at runtime. MyPy builds them by looking at your source code and analyzing it. So basically, if you want MyPy to see something, understand something in your program, it has to be explicitly in the Python source code. So if you use some dynamic magic, you might have to give MyPy a little help. And symbol tables can be nested. So clearly, like a module may contain a class, and a class may contain a nested class, and so on. So next, I'm going to show you a simple example. So this is a symbol table for a class from the previous example used in the demo. So we have a class account, and below the source code, we have a symbol table for the class. So this is for the class, not for the function or the method under init. And we can see that it has three things. First, we have under init. So MyPy looks at the definition of the class and sees like what are the kinds of things that the class will have at runtime. So clearly it has a method under init, and MyPy looks at the signature and sees like it's a self-argument, a name, and a balance. And from those, it derives the static type of this method, which is internally represented as a callable type. And MyPy automatically infers that the self-argument has a type account, because it would be kind of like silly to have to always write that down explicitly. Then MyPy will look at within the body of under init, and it sees that, okay, you're assigning to an attribute called name through self. So this defines an attribute, and it looks at the initializer, or the right-hand side of the assignment, to determine the type of the attribute. In this case, it knows that the name is a string, so the type of name is also, the name attribute is also a string. And similarly, it sees that you also assign to the balance attribute. And again, like this, the type of the value is float, so the type of this attribute, again, is float. In this example, we have the donate function from the demo. And here we build a symbol table for a function. So this is a little different in that the symbol table for a function is only used when type checking a function. It contains local variables, and those aren't visible outside the function. But they are still really important when actually type checking a function. MyPy goes through the statements within the function and kind of gradually builds as a symbol table. Initially, we have entries for all the arguments of the function, and the types are derived from the declared types. So here we have like bank, names, and amount each. This is pretty straightforward. Then MyPy looks at assignment. So a key thing to keep in mind is that MyPy considers like a first assignment within a source file to a particular destination, like a variable, as the definition of the variable. So it is a first assignment to total. So MyPy says, okay, you're defining a total local variable, and it looks at what you're assigning to it. Oh, it's a float. So MyPy adds total to the symbol table with a type float. On the next line, there's reference to names. So MyPy then doesn't immediately know what is this names thing. It looks at the symbol table for the function and looks, oh, the names is a local variable, and it is a type list of string. And that helps, okay, that lets MyPy understand what this for loop is doing. It can see like, okay, you're iterating over a list of strings, so the individual item is going to be a string, and we add that to the symbol table. So name is now a string. The next line is a little trickier. It actually has 3 references to local variables. The types of all of these are looked up from the symbol table for the function. And then MyPy looks at the method call. There's like bank.deposit. So MyPy understands, okay, bank had a type bank with capital B. Okay, then it finds, okay, now we need to know the symbol table for the class bank to understand what deposit means and whether it's a valid thing to do on a bank object. And luckily we have, that's fine. There's a definition of deposit, and it's visible in the symbol table. And MyPy looks at the type of the deposit to check that the arguments are compatible. And more importantly for this example, MyPy will say, okay, deposit returns an optional float. So that helps MyPy infer that the type of amount is clearly an optional float. The next line has another interesting bit. So it actually doesn't do much, it just checks whether amount is not none. And MyPy will understand this check and will see that, okay, because of this check, within this if statement, the type of amount is actually just float. It can't be none. So basically it replaces the type of amount with a more specific type. And this can happen more generally. So basically, a variable has a type, but it can have like different types in different parts of the program. And this is really important to let MyPy understand MyPy idioms. And this is quite different from statically typed languages like Java or C++, where you generally would have like special syntax for this sort of thing. But maybe MyPy is pretty clever about it, and it can understand this and like much more complicated examples of runtime type checks and runtime kind of non-checks. And now MyPy can type check the if statement, the assignment in the if statement. It sees that, okay, the amount is just a float, so adding a float to a float is valid. But this wouldn't have been valid if you had an optional float. And then, finally, outside the if statement, the type of amount kind of reverts back the optional float, because the check isn't applicable there anymore. Okay, now we saw a few examples of using mypy in the small, for pretty small and simple programs. And it seemed to work pretty well. But what about if you have like a large program or medium-sized program, but you have like hundreds of files or thousands of files, and they have no annotations at all? Then how would you go about starting to use mypy? Let's look at that a little. The first thing that probably comes to mind, okay, we'll just do the same thing as David did during the demo. We just run mypy main.py, assuming like main is the main entry point to your program. And this is often a totally reasonable thing to do. But let's see what happens when you do this. So mypy starts with processing the module main, and then it finds all the imports within that. So in this case, it imports view and model. And mypy looks at then view recursively, and so on. It goes through like all the modules that can be reached from a main recursively, and like type checks all of them. And what does this imply? So if you have hundreds of thousands of files, it means that, because mypy, as we saw that mypy sometimes needs a little help, you might have to add an annotation or maybe tweak your code a little to get mypy happy. If you have a lot of code, then that might mean like a lot of kind of small things, tweaks that you need to do. And that would be, yeah, that can make you pretty unhappy if you see like 200 errors when you run mypy for the first time. But don't worry, this is generally not actually a real problem. You just need to do things a little differently. In particular, you should probably annotate your code like bottom up. Let's see what that means. So instead of starting from the main entry point to your program, let's first type check just some like leaf module that doesn't import anything, or just imports like a few simple things. For example, util.py. So we run mypy util.py. Again, like maybe you need to tweak it a little, but probably just a single file, so it's probably pretty simple. So in this case, this is one thing that mypy complains about, like need type annotation for variable. Okay, there's again like you assign an empty list, and mypy has no way of knowing what the item type is, and it doesn't want to kind of guess or make assumptions. In this case, so we'll just add an annotation, and then mypy is happy. And then we basically find what are the things that we can, are there other leaf modules, or maybe something that we can like depend only on things that we've already annotated. And also, before you move to view.py, you should probably add some annotations to util.py, because then when you view that module calls into util, then we can type check that those calls are valid, and we like can infer use the return types to do type inference within view. So as I said, and David said, like adding annotations is important. Just running mypy against your code otherwise isn't going to be super helpful. So the next step is to run mypy with two arguments, util.py and view.py. And then if there are any issues, then we fix those, and you add annotations to view.py, and so on. So next, we could process like model.py, and finally, main.py. Eventually, you might have a fully annotated program, all built gradually, and you have like a clean mypy run multiple times during the middle, so you don't have to do it in one go. Okay, sometimes things are still a bit more complicated. So maybe you're using some third-party library that mypy doesn't know about. Maybe you have like import cycles, like multiple modules importing each other. Or other, like maybe your code base is super, super large, and you can't afford to like do this like bottom-up thing, because maybe some things just, you have to kind of focus on the most important bits, and maybe those are in the middle or towards the top of the the module hierarchy. Again, like, yes, this is actually what we had to do at Dropbox, and yes, mypy supports it. So these are a couple of options that you can use to run mypy, which basically tell that only type check these modules that I explicitly give you as arguments, and basically ignore everything else in the program for now. So this lets you kind of focus on a specific subset of your program, and then kind of gradually increase that subset as you go on. And there's one thing that I'd like to kind of tell you now. Now you do this, like if you're doing this gradual migration, adding annotations and adding more files, it's really important that you keep like the mypy run against your code clean, so there's no output at all times, because otherwise it's really confusing. People won't be able to see whether this error is something they caused or whether it's caused by somebody else. It's the same as a test suite, so you want to keep the tests always passing. And our recommendation is to run mypy when you run your tests. So basically mypy is just kind of another test that keeps your code base healthy. You can use like your CI system, such as like Jenkins or Travis, to do this. It's pretty straightforward setup and really helpful. And if you're annotating a large code base, you probably don't just want to run mypy or have your engineers run mypy directly. So what we did at Dropbox is we have mypy runner script that everybody uses to run mypy within for a particular project. So what does this runner script then do? It sets mypy options, so that everybody's using the same options. It controls the mypy version, so that everybody's using exactly the same version of mypy, because otherwise like there's slight differences between versions, and we want everybody to get the same results. Also, you don't want to manually keep track of the list of files within your 1,000-file code base, those that are being type checked. So basically what we did is we basically find all files just using like shell commands, like find and grep, find all files with type annotations, and only include those in the mypy run. So adding a new file to the build is as easy as just like adding a type annotation somewhere within a file. And also the script is committed to the repo. So if you have a local branch, you always use the right version of the repo, and you get like consistent results in CI, because the CI is also using the same version of the script. So the result is consistency and repeatability, and those are really important, because initially before we had all of these things implemented, so many like wasted hours when people like, why is this like the CI build is coming up green, but locally I get all these weird errors. I don't know what's going on. It's just they're using slightly different things. Okay, these instructions should be pretty helpful and help you move forward. But there's some like subtle things you might encounter depending on like how your code looks like. So one thing to remember is like mypy is configurable. A lot of options. It can like you can easily get it to ignore errors and focus on only certain kinds of errors. So you just don't give up when you first hit issues. So read the documentation. It's really helpful. Some things are not obvious if you just start playing around. And we also have a Gitter chat, and there's almost at any time somebody there who can help you, like other like users of mypy, the dev team, and other contributors. Next, I'm going to talk about experiences of using mypy at Drop. We have 700,000 lines of annotated Python at Dropbox, and we started from 0 about 18 months ago. And most of this has been annotated by like engineers, other engineers, not like the mypy developers. We basically just provide the infrastructure and the tool for them to do that and help them like use mypy effectively. At Dropbox, we still mostly use Python 2. And what we saw is not valid. Like the examples use Python 3, function annotation and variable annotation syntaxes. But that's no problem. There's a comment-based syntax, which isn't quite as pretty, but it works the same. And that works both in Python 2 and 3. And we also have some code that's being migrated to Python 3. And there it's helpful to run mypy in both Python 3 and Python 2 modes to find automatically some like compatibility issues that it's pretty easy to have. Next, what have we learned from using mypy Dropbox? So as alluded in the motivation, types really make your code more understandable. And that's because engineers spend a lot of their time reading code. This is really important. The basics makes them more productive. There are two ways in which types prevent bugs. First, as we saw, like mypy will catch many errors in your code before you run the code or before you submit it for code review. But there's another more subtle thing going on. Because types help you understand your code, you're less likely to actually write the bugs initially. So that's even a bigger savings. And it's really helpful. And IDEs also can benefit from type annotations. So for example, PyCharm code completion, it's much more powerful if your code is annotated. And again, like this is really helpful and makes you more productive. Refactoring is really, really nice if you have static types. Because most refactorings are kind of simple things like add an argument, move this thing to another file, or maybe a little more involved, but still, most of those things are actually things that mypy can automatically catch. So if you have fully annotated code base, mypy can tell you when your refactoring is like correct and finished. All of these benefits are important for almost any size of code base. But in our experience, like the larger your code base, the more important these are. And when you have like millions or hundreds of thousands of lines of code, types now in retrospect seem pretty much essential. So like once you have types, you don't want to go back. It really like makes a difference. So here are some quotes from Dropbox engineers after they started using mypy. In general, like the internal feedback has been overwhelmingly positive, and engineers are happy about using mypy. And as I said, like most of the adoption is from the engineers, and generally they decided to use mypy. It's just like mypy team can't tell them to force them to use types. It's their decision. Okay, so how would you get started? So you can just install mypy using pip3 install mypy, or the another like lengthier version. And you need Python 3 to run mypy, because mypy code base uses Python 3 annotations because they are nice. But you can still type check Python 2 and Python 3 code. And again, like you should really put in annotations, otherwise mypy can't do a very good job. mypy is an open source project. So Dropbox contributes to the core development team, but we have like a lot of outside contributors as well. And we are like open to new contributors. If you're excited about compilers or like type system theory, like please consider like contributing to mypy. I think it's a pretty cool project. Well, obviously I'd say that. And as I said, we have chat on Gitter, where you can ask any questions, and it's a friendly place. So if you have any trouble, no question is kind of too silly. And if you start using mypy, you should follow the mypy blog. mypy development goes pretty quickly, and we have releases pretty frequently, and new things get added and fixes get implemented all the time. So you should follow that to stay up to date. And we are going to be at PyCon sprints from Monday till Wednesday. So if you want to see like what hacking mypy looks like, then come and join us. And thank you.
Okay, we have time for some questions for a few minutes. So if you have a question, walk up to one of the microphones.
Do you just ask, or go ahead? Okay, so you can use the if statement and checking whether something is a none or not to take an optional and convert that into an unwrapped type. can you do the same thing with a union and an is instance check?
Yes.
Yeah, MyPy understands actually several things for none also. It'll understand just truthiness checks, because none is always falsy, and some other things of that ilk. And
Yeah.
if there's some, we think we have most of the main paradigms for checking stuff like that, but if there's something that we've missed, we definitely would want to add it.
Yeah, also MyPy knows about is subclass. That's a recent addition.
In your mypy script, you mentioned you create a list of modules that are annotated. Do you have a way of automatically determining that, or you just, once you do one, you put it on the list?
We do it automatically. We actually grep through all the files for type annotations and add them that way.
Cool, thanks.
It works pretty well in spite of sounding a little sketchy.
Yeah, it's really useful. Yeah, maintaining the list manually would be like a huge pain.
So I use type annotations in a pretty large project that I'm working on, and hadn't heard about mypy. I just used it because it was in the PEP. So my question is, how do you handle methods that return types from third-party modules that aren't exposed or exported? So, for example, PyCharm can't actually see what they are until runtime.
Let's see, so if I understand the question correctly, it's about what do we do for types that aren't exported from third-party modules?
Yeah, and how do you, like, if I was to start using mypy, how do I tell mypy to just ignore it, because it's not going to be able to know it until runtime?
Yeah, this is sometimes a problem, but basically to type check code using modules like standard library modules or third-party modules, we use stub files, which basically describe the public API of these modules. And these stub files live in typeshed. And those stub files, because they aren't executable, they are only used for static type checking, they may actually contain like types or classes that actually don't exist at runtime, which is kind of hacky, but you can then use those classes in the stubs and in your code by using like string literals, so putting string literals around the types, and then it doesn't get evaluated at runtime, but you can still use it for type checking.
Is there any concern or discussion around how to use some of these tools with duck types?
Yes, we're currently evaluating, there's a PEP, which PEP number is it again for protocols? I don't know, there's currently a PEP for protocols that's in the works. Protocols basically are static duck typing. It's something that we are seriously considering adding to mypy, but we'll probably take a considerable more amount of work before we do so.
Yeah, you can use like things like iterable and sequence, so those are defined in the typing module. So they're kind of like duck types, but you have to be a bit more explicit about them. But mypy will understand that, for example, a list is an iterable. Yeah, that works.
So that's a good point. So we have, Python for a while has had like a rich set of abstract base classes. And for most use cases so far, we found that using those in place of duck typing has actually been pretty nice. And in some ways, it's nice because it's more explicit and can be a bit more readable. So that's been our experience so far.
How does mypy deal with my custom C extension if I use it, and how can I force mypy, or what can I do to force mypy deal with this extension?
That's a good question. So mypy is not going to try to look into the internals of a custom C extension and understand it. That's a very difficult task. Instead, you can write what's called a stub file, which we mentioned earlier, which is kind of like a C header file for Python. It just has type information. So you can write a stub file for your C extension, which tells mypy, hey, here are all the functions, here are all the types that they have, and then mypy can type check it that way.
I will continue. And if my extension provides some class for Python?
You can also put that as part of the stub file.
Okay, thank you.
Do you think it would ever make sense to, assuming that generating the symbol table is expensive, and if it's per module, like caching it locally and then updating it whenever like a file change, like you're listening to it, if that makes sense?
If I understood you correctly, yeah, it's like caching like a symbol table from the previous mypy run to speed things up. Is that correct?
Yeah,
Yeah, you can like use the incremental mode.
So basically we do that.
It basically does that. We do that. Yeah.
Cool, that was my
But
idea.
you have to like explicitly enable it, but it works. It's useful.
So good thought. Also a quick plug just before everybody is gone. We're going to be having an open space at 2:30. If you're interested in joining us to talk about static types, we'll be in room B110 and 111.
Hey, so I understand the reasoning behind like the
differences between places where you have type aliases like capital L list and just using like str and stuff like that, and the exceptions like named tuple. What is the kind of vision for the future of mypy and typing in general? Like, what would you like to see it ultimately look like? You know, are you planning on ironing out those kind of exceptions, or?
I'm not sure I fully understand your question, but insofar as we have, you know, like list of string, dict of string to account, stuff like that, we're pretty happy with that syntax, I think. It seems to work well in our experience. There hasn't been a big issue with it being slightly different from just using, you know, lower d dict directly. And so we think that, at least in that part of mypy and that part of type annotations, it's likely to continue to look similarly to how it does now.
Cool.
Yeah, it's basically fine, but I think, yeah, they've been like discussions like that, so I guess it's, we don't know
The
what
name
will
tuple
happen.
thing is really what I mean, like how that's, you can
Yeah.
call that, but not others. Like, would you like all of them to be callable or none of them, or?
Yeah, this is basically current status, even though there's like a little repetition, but based on experiences, it actually doesn't matter that much. It's basically good already. So things might improve in the future, maybe, but I think that's basically they're good enough already.
Thanks.
I work with a couple of guys who would say types. That's not Python. I don't know. I've encountered some kind of almost cultural resistance, and me moving in that direction personally. Have you gotten a lot of resistance, as if you're like breaking what makes Python so great?
That's a great question. So at Dropbox, generally people have been pretty excited about types. We've had a really pressing need for them. With regards to it being Python or not, this is actually something that Guido's been thinking about for a really long time, back since about 2000, and he has some blog posts online where he actually lays out something that looks very similar to what type annotations look today, as a perspective idea. And so, insofar as Guido is the BDFL of Python, types are pretty declared to be Pythonic. So I don't know how much that will help. You know, nobody's saying all Python should have types. No one is saying that whatsoever, but types as an optional part of Python that you can use when it makes sense is absolutely, you know, considered Pythonic from the top at least. So I don't know if that will help with those colleagues or not. Maybe if you know if you can convince them to try it out, or if you add it in a bit of the code base that they interact with, maybe they'll find that they like it.
Yeah, give it a try. So basically, a lot of people who are kind of not convinced about the use of types, when they actually use them, then, oh, this is actually pretty nice.
Okay, we're a little over time. One more question.
Yeah, so in the case where it makes sense, can you use mypy in a runtime environment to validate, say, user input is consistent with a type annotation on a method, something like that?
That's not really supported. So mypy only runs statically. So, but the type annotations themselves, if you're using Python 3, are available for introspection. So basically, you could build something on top of those, but mypy, would be a separate thing from mypy.
Okay. Do you know if there's a library that does that?
There's something called like typing inspect. I think that's being developed, which would let you kind of introspect the types and see like if you have a list of int, you can like query the list item type and things like that. Okay. So it's in the works, but I think it's not quite ready yet.
Thank you all.
Yeah.
Sure, we understand what these 3 short lines do. And this is not a great place to be. It takes a long time and can be a bit unreliable, and is just generally not super fun. So how might we go about fixing this? Well, this is a big enough problem that some people have suggested rewrite all of our code in a statically typed code base. This is in spite of the fact that we have 5 million lines of Python code, and this would take far, far, far too long. This is also notoriously a way to end up having your company crash and burn. Joel Spolsky wrote a great article on this about Netscape. And finally, Python is pretty hard to beat. We're here because we're excited about working in Python. I assume that's why you're all here too. And so we don't want to do this. We want to stay with Python. So, all right, that's no good. What are some other options here? Well, potentially we could add some sort of special doc strings or comments where you always write the type in. And this works OK at first. Now you have the type next to the code, and you can figure it out easily. But people forget to update them over time. And this can happen for a variety of reasons, even with good code review and the best intent. Sometimes you'll make a change far away in the code base that ends up having some effect on the types downstream that you don't even really know about. And so over time, you're almost certain to end up with some percentage of these doc strings no longer being true. And once they become untrustworthy, they start very quickly to become useless. After you've been burned by this a couple of times and gone on a wild goose chase for a few hours, you no longer are willing to trust any of the doc strings, even if only a few of them are incorrect.
Okay, we're going to get started. We have Jukka Lehtosalo and David Fisher. Thank you, guys.
Thanks, Tim. So my name is David. This is Jukka. We've been working on Python static types, more specifically mypy, a Python static type checker at Dropbox for the last while. And we're here today to tell you all about it. More specifically, we'll start with talking a little bit about the motivation behind our work on this, why we think static types are important. Then I'll show you a brief live demo of what it would look like to add static types to your code, what static types look like, what interacting with mypy is like, all that sort of thing. Then Jukka will talk a bit about how mypy works internally. There's a lot going on, but it'll focus on a particular interesting part of it. And then we'll give you some tips for annotating an existing code base, and finish up with our, and we've done it, and it works. And we're using it at Dropbox on 700,000 lines of code, and a number of other companies in the industry, like Quora and Facebook are using it, as well as big open source projects, like Zulip. So we're very excited about that. And that's what we're here to talk to you about. So I've talked a lot about why we've done this. Let me show you what it is that we've done. So I'm going to attempt to do a live demo, because those always go very well. And to do that, first I'd better show you my screen. And it would be really great if the mirroring would show up, but maybe it won't. So let's just do this. Huh? Command F1? All right, let me try that. Well, this didn't happen in run through, so we'll figure it out. I'll use that. Sorry for the slight technical difficulties. Great. Nope. Pardon me. Sorry for the fiddling. Great. So, all right. So I can sort of see my code. So that'll be exciting. Probably don't need this Vim help file right now. Great. So I have here a pretty simple bank program, which I will endeavor to view. As you can see, it has an account type. There's a bank class where you can do things direct. And this is a pattern that we've seen in a number of large code bases. So this is not going to work for us either, unfortunately. Another option that some have considered is doing type inference through the whole program. So don't write anything else in the code, and just have some really, really smart analyzer that is able to understand your millions of lines of Python and tell you what the types are. And sure, the types aren't in the code, so you'd have to have some utility that displays them, but that seems potentially possible. But there's a bigger problem, which is this is an unsolved problem. Nobody really knows how to do this. They do know that it's very difficult, but no one so far has done this successfully at a very large scale. And worst, if you have some dynamic part of your Python code base, then that will blow the whole thing up. The static analyzer will, or the whole code base type inferencer, will look at that dynamic part. It won't be able to make heads or tails of it if it just does something truly dynamic. And it'll not be able to make any inferences about your code as a whole, or at least very limited ones. So that won't work for our purpose. So OK, what can we do? Well, what if we added static types to Python? You'd have to be able to introduce them gradually, otherwise you'd be back to the rewrite everything in a static language problem. But this is possible. It would document types right where you want to see them, and it could check that documentation to make sure that it stayed correct. It would still be a lot of work to implement, and it still had some legitimately unsolved problems, but it was doable. Experiences at Dropbox and how we found it so far. So to start with, let's talk about why are we doing this whole static typing thing anyway? Well, one big reason is to be able to answer a question like this. What does this code do? If you're in a large code base, this may be a common experience. You have some two-line function that's pretty simple on the surface of it, and you need to understand what's actually going on. Unfortunately, it's not a super easy task. Let's say you want to know what entry.data.validate does. How might you actually go about figuring that out? Well, you could grep for a validate method, but in a large code base, you're going to get a lot of results. In Dropbox's code base, we have 154 results. And these aren't related by some common superclass or anything. It's just a popular method name. So that's not really that helpful. We don't really want to have to read through all 154 validate methods to try to understand which one this might be. So if we knew what an entry.data was, we would be able to figure this out. And we could know that if we knew what an entry was, which we could know if we knew what an entries was. But how do we figure out the type of entries? We could try to guess from context, but in this sort of function, that's not really helpful at all. So we could grep for call sites of validate entries, but now we're kind of just back where we started. We may have to look through maybe there's a lot of call sites. Maybe some call sites pass in one sort of entries, and some call sites pass in another. It's easy to miss one of those. So we are potentially having to read through thousands of lines of code just to be